Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos, Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 6 on financial maths. Says in 6.1, Patrick deposited an amount of 18,500 into a savings account earning R% interest per annum compounded monthly. After 6 months, his balance was 19,319.48. Now in 6.1.1, they say calculate the value of R, right? So now we're going to say 6.1.1. Obviously, reading this question here, we can see that there are no regular payments that are being made. The 18,500 were just deposited into a savings account, and then it was left to accumulate interest for a period of 6 months. So obviously, the formula that we have to use is the one that you know from all the way in grade 8, which is your compound formula. A is equals to P bracket 1 plus I to the exponent of n, right? So the A here is for the accumulated amount, which is 19,319.48. Then the principal amount, which is the one that was being deposited initially, and then we have 1 plus. So the interest here, note that this is compounded monthly, so this should be I over 12, right? And then right here, we have the n, which is 6 months, right? So note that we are already given in months. So we do not say 6 multiplied by 12, right? Remember, you only say multiply by 12 if you are given in terms of the number of years. So what we are trying to do with that is just converting the years into months. But if you are already given in months, then you just simply take what you are given here and then substitute it here, right? So always pay attention to that. If you are given in months, just simply substitute that there. If you are given in terms of years, then that's where you need to multiply by 12. Okay, so now at this point, we divide both sides by 18,500, like that. And then we can make that the subject of the formula. So the exponent of 6, and then is 19,319.48 over 18,500. So now we do understand that in order to get rid of this exponent 6, we have to insert root 6 in both sides, on both sides. So just like that, and then we are left with 1 plus I over 12 is equals to, so if we punch this into our calculator, we end up with 1.00725. So you do understand that there are still more decimals that are following there, but I'm just gonna write 5 decimal places for the sake of the question here. Then I have I over 12. So you can keep this in your calculator as a decimal and then just simply write answer. So you know from your calculator it saves the answer, so you just say answer, and then when you transpose the 1, it's minus 1. So you'll have 1.00725, which is your answer minus 1, right? And then I over 12, this here will give us 0.00725, and then when we cross multiply with the 12, our I is 0.087 and a whole lot of decimals, which if you are looking for the interest rate R%, then you have to multiply this by 100. Because remember, when we are writing our I, we already have divided by 100. So if you want to take it to R, then we need to reverse that and multiply by 100. So to have our R interest rate, then that's 8.70%. So this is what we call the nominal rate. So hence in 6.1.2, we are being asked to calculate the effective interest rate. So this is the nominal rate. And then now let's calculate the effective interest rate. So in 6.1.2, let's now tackle that. We have 1 plus I effective is equals to 1 plus I norm over m to the exponent of m. So you will remember this formula from your grade 11. So to calculate effective interest rate, all we have to do is substitute into this formula here. So we have our 1 plus the nominal interest rate, that's the 8.70%, right? But then remember, when we put it here, we need to already have divided by 100, which will give us 0.087. So 0.087. And then since it's compounded monthly, remember, if it's compounded monthly, we have 12 and 12 here. If it's quarterly, we have 4 and 4. If it's semi-annually, we have 2 and 2. So this is monthly, so it's supposed to be 12 and then 12 over there. Then to calculate our effective interest rate, we can just write this first, all of this, and then transpose our 1, so that we can just simply punch all of that into our calculator and get our effective interest rate. So this will give us 0.09055 and a whole lot of decimals, which we then need to multiply by 100. So our effective interest rate is now 9.06%. Right. That's how we calculate the effective interest rate. So only for 2 marks. So you understand that you just need to be very quick with your maths there. Okay, so in 6.2, they say Kuda bought a laptop for 10,000 on 31 January 2019. He will replace it with a new one in 5 years' time on 31 January 2024. Now, 6.2.1 says the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. So again, straight line method, you will remember from your grade 11. And then they say after how many years will the laptop have a value of 0 rand? So after how many years will this laptop have no value at all? Right. So let's now calculate that. Remember our straight line method. From our grade 11, it's A is equals to P, 1 minus I times N, right? And then remember, the A here stands for the book value or the scrap value after the depreciation period, right? So after the depreciation period, we will have our value being 0, right? And then what was the value before the 5 years? So that's 10,000, right? So we have 1 minus the interest here, 20%, but then remember, that's 20 over 100, which will give us 0.2. So we have 0.2 and then N here, right? So we are looking for that N, the number of years. Now note that when we are dealing with depreciations, always our depreciation period will be calculated in years. So there's no depreciation that happens on a monthly basis. So all depreciations take place on a yearly basis, right? So we will always have to look for the number of years here. Now, obviously, to further calculate here, we have to divide both sides by 10,000, which we do understand dividing any number to 0 is just 0. And then that's 1 minus 0.2 N, right? Now, obviously, let's make this one the subject of the formula by bringing it over here. And then we just leave the 1 here. Divide both sides by 0.2, 0.2, and then our N is 5. So that's 5 years. So that means exactly after 5 years, when it plans to replace the laptop, it will already have a value of 0 or no value, right? So that means Kuda will not be able to sell the laptop after 5 years. He would just need to give it away for free, right? Or give it to his younger brother. Okay, so 6.2.2, Kuda will buy a laptop that cost 20,000, will buy. So this is in the future, right? So always pay attention to the way they write your statements. They kind of give you an idea as to which formula you should use. So Kuda will buy a laptop that costs 20,000. We can see that this will happen in the future, right? In order to cover the cost price, he made his first monthly deposit into a savings account on 28 February 2019. Remember, the statement here was saying initially he's planning to replace the laptop in 5 years' time. So that's in future. What formula do you have to use? Future value. Where's the 20,000? It is not with Kuda. He's still planning to save that 20,000, right? So that's the difference between knowing when to use future value and present value. Always ask yourself this question: where is the money? Is the money here presently, or is the money still to be accumulated? Right? If the money is still to be accumulated, that's future value. If the money is already here presently, then that's present value. Then he will make his 60th monthly deposit. So this here, again, it's a giveaway in terms of what you should use for your N. He will make his 60th monthly deposit on 31 January 2024. So that means how many monthly deposits will he be making? 60. Right. So that's the final payment. The 60th monthly deposit is the final payment. The savings account pays interest at 8.7%. Per annum compounded monthly. Calculate Kuda's monthly deposit. So what are we looking for? The monthly deposits, those are your X. Yes. So that's your X value, right? These are your regular payments. Then, okay, we have established that we need to use the future value. So we're just going to write it like that. The choice of a formula, guys, on its own, it's a mark. The choice of the correct formula to use is a mark on its own. So you need to really pay attention to that. Okay, so now our future value, this is the money that he plans on saving, 20,000. And then X, this is the monthly deposits that he'll be making, which we are trying to calculate. Then we have 1 plus our interest. Again, we divide this one by 100, so that's 0.087. But then since it's compounded monthly, we have over 12. And then here, note, we can't say 60 multiplied by 12. We are already given in months. They're saying monthly. So we just go here and say 60, right? So which, if you can check here, it corresponds exactly to just taking the 5 here and multiplying it by 12. If you say 5 multiplied by 12, that's still 60, right? So 60 monthly deposits in a period of 5 years. So that's 60 months in 5 years. Then minus 1. Now, obviously, the question is, why don't we add 1 on this one? So you know some of the questions we are used to adding the 1. Now let's read the statement carefully. Remember here we are being told that he will replace it with a new one in 5 years' time on 31 January 2024. And then when is he planning? They say he's planning to invest starting from 31 January 2019. So that's the plan here. That's when he goes to the bank and talk the terms, right? But then now he makes his first monthly deposit 1 month after the discussion. 1 month after visiting the bank, he makes his first monthly deposit, right? So note that we don't add 1 if he makes the monthly deposit 1 month after the savings account has been opened. So he does not make the monthly deposit immediately, which is why we are not adding 1. If he makes the payment immediately, that's plus 1. If he doesn't make the payment immediately, makes it 1 month after the opening of the savings account, then that means we do not have to add the 1. So always note that he made his first monthly deposit into a savings account on 28 February 2019. But then when did he go to the bank and discuss the terms? 31 January 2019. So the deposit was only made a month after. So here we have 0.087 over 12. Now to be very, very neat with your maths, all you have to do is take this, cross multiply it with that one. So note, you make X the subject of the formula, take this 20,000, cross multiply with the 0.087 over 12, and then just take all of this. So whenever you are calculating the X amount there, whenever you are calculating the regular payments, this is always the method. So take this, cross multiply it with that one, and take this portion here over to the denominator. So it makes everything quick, because remember, they're not going to mark all those steps that you constantly write when you are solving this question. It's only the formula, substitution into the formula, and then now they're looking for the correct answer. So you need to be very, very quick, because if you try to write all that, it can be time consuming. And then you're just consuming time on steps that do not offer you marks. Okay, so now when we punch all that into our calculator, we end up with 267.27. So this becomes our monthly deposit. So the monthly deposits that Kuda makes into this account in order to raise 20,000 to buy the laptop in 5 years' time. Okay, so now let's proceed to 6.2. They say Tino wins a jackpot of 1,600,000. He invests all of his savings in a fund that earns interest of 11.2% per annum compounded monthly. He withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 will Tino be able to make from this fund? Okay, so note this. With this question, there's been a debate as to whether the future value formula or the present value formula should have been used. Now, I know that the confusion comes from the part that most of the time when you are being taught in class, you are told that everything that says investment or savings should relate to your future value, right? Now, to some degree, that is not wrong. It is quite correct. But then now note that this is a different case. Tino wins a jackpot, and then he has this money, 1,600,000. Now, if we go back to the question where I said, if you want to decide whether it's future value or present value, you just simply have to ask yourself this question. Where is the money? Is it here presently, or it is still yet to be accumulated in the future, right? Now, we can see with this case here, Tino has already won the jackpot. Where's the 1,600,000? It is with Tino. And then where is he taking the money? To this fund, so that it can be paid 20,000 every month, right? So in a way, the fund is paying him 20,000 per month. So now the fund is saying, yes, thank you for giving us the 1.6 million. We want to use it for our own financial gains, but then we agree to just paying you 20,000 per month, right? So this is the case that is happening here. So in a way, it's more like Tino is now loaning the fund, right? And then the fund in return is paying Tino for having to put the money in the fund and just assisting the fund to grow in their financial needs or whatso not, right? So whatever they do with that 1.6 million, as long as they just agree to pay him 20,000 every month. So you get the case that here, this is not a future value. He is not investing the money so that it grows. He's just investing the money so that every month he can be able to withdraw. So Tino just don't want to be a part of those people that out there saying that I blew it. So he's now being smart about it and saying, let me put it in a fund and then I'll just be getting this 20,000 as if that's a salary, a monthly salary, right? So the money is already there. That means the formula that we have to use is present value. So that's the question. If the money is already here presently, present value. The money is still yet to be accumulated, future value. Okay, so present value, x 1 minus 1 plus I to the exponent of negative n, and then over I. So present value, that's the money that he invests into the fund. And then x, the monthly deposit or the monthly withdrawals, meant to say, that he makes. And 1 minus 1 plus interest, 11.2%, which we have to divide by 100 to give us 0.112, and then over 12 since it's compounded monthly to the exponent of negative n, then close the bigger bracket. So make sure that you are very careful with punching in your brackets here, because one mistake, you can just find yourself with a very weird answer. So, okay, the first thing that you want to do here, note that I always say, keep your maths clean and neat. So the first thing that you want to do is you want to divide by the number that will be here, both sides. So what number do we have here? 20,000. So you want to divide by 20,000 both sides. So if you divide the 1,600,000 by 20, you end up with only 80. So now we have 80, and then here we'll only be left with 1 minus. Remember, we've divided by the 20,000, so we only have 1 here. Then 1 plus 0.112 over 12 to the exponent of negative n. Okay, let me... So I have the 80 here, and then 1 minus 1 plus 0.112 over 12 to the exponent of negative n over 0.112 over 12. Now at this point, do you understand that we can just cross multiply this? So take the value here and then cross multiply it with the 80. So we'll have 80 bracket 0.112 over 12 is equals to 1 minus 1 plus 0.112 over 12 to the exponent of negative n. Right. Then at this point, if we want to have our logs, all we can do here, okay, if we want to further calculate, so this will not be abracadabra, but then I'll just be taking this over to the left-hand side and then taking all of that over to the right-hand side. So I'm trying to make n the subject of the formula. So I will have positive. Remember, it's negative. When it jumps over, becomes positive. And then to the exponent of negative n. Now we are left with this one here. But then this, when it jumps over, it becomes minus 80. And then 0.112 over 12. So I hope I'm not losing anyone there. Okay. Now at this point, this is the point where we now apply our logs. So we make negative n the subject of the formula. And when you're applying your logs, you need the log with 2 blocks there. So we have the log with only 1 block. And then we have the second function of log, which is the one with 2 blocks. So you need the log that will say log, block here, and then block here, right? So you need to punch this one. I think if you have your casual calculator, that's shift log, so you find it, it's there written like that. So, okay, now when you apply your logs, then that means you say log, the base will have to be this one. So the one on the lower block, you put this number here. So that's 1 plus 0.112 over 12. And then on the upper block, you will put the answer that you get from punching this. So if you punch 1 minus 80 times 0.112 over 12, the answer that you get from here, that's what you put in here, right? So if you have already saved it in your calculator, you can just say answer here. And then if you punch it in, or if you just punch this into your calculator, then it gives you, so punching that into your calculator, it gives you 19 over 75, right? So 19 over 75. Now you simply just have to punch all this into your calculator, the log, base 1 plus 0.112 over 12, and then 19 over 75. And then it will give you negative log. Obviously, the answer that you must get here must be a negative. So it's negative 147.79, right? Then if you divide both sides by negative 1, then your n becomes 147.79, right? But then remember, here, the question was, how many withdrawals of the 20,000 will Tino be able to make from this fund, right? Now, a lot of you miss the final answer by just wanting to round off this. So a lot of you, knowing that you have to round off to 2 decimal places, would say
he will make 148 payments, which is incorrect. Now, understand when it comes to this, there is no rounding off that will be involved. This thing has its own meaning here. The 147 here is speaking to the full 20,000 withdrawals that he will be able to make. So he will be able to make 147 20,000 withdrawals, right? So 147 payments of that or withdrawals. Then what about the 0.79 here? If you say 147.79 minus 147, you will get 0.79. So meaning the last withdrawal that it will make will not be the 20,000. It will be an amount that is less than 20,000. However, it will be a withdrawal, but then it won't be the 20,000. It will probably be an answer that is less than that. So when I calculated, just to confirm, I got 15,669.1529. If you want to confirm it, it's very simple. All you have to do is go back to this formula here. Put your 20,000, write the formula as it is with everything substituted, but then on your value for n here, substitute 0.79. Substitute this value here. So which will be indicating the last withdrawal that will be made. So also this question appears, so we'll try to look for a question that is similar to that one. So if you want to know the last withdrawal that will be made, the amount that will be made as a last withdrawal, all you have to do, take this value, subtract the whole number here, which is before the comma, and then you'll be left with the decimal. Take that decimal, put it on n, and then you'll be able to calculate the last withdrawal that will be made, which is, I already said, it's 15,669.1529. So I stand to be corrected if I got it wrong, but then it's somewhere closer to that or exactly that. So, okay, in conclusion here, what we are supposed to say is that he will make 147 withdrawals. So he will only be able to make 147 withdrawals of the 20,000, by the way, of the 20,000. It's not 148. You don't say, but it's saying 0.79. Why don't we round off to 148? Yes, he will be making 148 payments, but then 147 of them will be the full 20,000. And then the last payment will be an amount that is less than the 20,000. Here we are interested on how many withdrawals of the 20,000, not how many withdrawals will he be able to make all in all. So it's only 147 that are the full 20,000 withdrawals. And the last withdrawal will be an amount that is less than 20,000. So that's how you go about answering this question here for all a total of 16 marks. So it was a very interesting question. Make sure that you also do it on your own and just come back and just check your own findings and your own answers against mine, and then try to just use it as a practice question to improve yourself. So with all that being said, please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.